In this video note, we should be taking some preparatory steps that lead up to taking our first proper look at how Java source code is used to define classes. We won't actually look at the source code in this video note, that will happen in another one. Here we'll do some groundwork that will make it easier to understand the source code when we see it. We shall be using the Naive Ticket Machine project from Objects First with Java by David Barnes and Michael Curling. We shall assume that you are already familiar with the fundamental terminology that we use throughout the book, either through previous video notes, earlier chapters, or both. Terminology such as class, object, method, parameter, field, and state. If you're unclear about any of these elements, take a little time to review the previous chapters and video notes to clarify any areas that you're not sure of. Here we have the Naive Ticket Machine project. Notice that the project is a simple one. It consists of just a single class, Ticket Machine. The Ticket Machine class is designed to model the sort of functionality that is commonly found in bus stations and subways, for example. The idea is that a customer inserts a predefined amount of money and a ticket is issued. For the sake of simplicity, there's no GUI associated with this project. The only visualization comes from the printing of tickets. Note too that we can only simulate the use of money with the machine, but that doesn't really matter for the purposes of this example, which is primarily to explore some of the most commonly occurring elements of Java source code. Before we look at the source code, it's worth exploring what ticket machines can do, and the best way to do that is to create one and try out some of its methods. If the ticket machine class has a striped appearance when you open the project, it must first be compiled. Now we can create a ticket machine object in the usual way by right-clicking over the class and selecting New Ticket Machine. However, note that there's a difference here from what we saw when creating shapes in the Figures project. We're presented with a dialog box requesting a parameter value. This is exactly the same principle as you will have met when calling methods that require parameter values. The only difference here is that we have to supply a value before the object can be created. The reason can be found by reading the text in the top section of the dialog box. This tells us that we are about to create a ticket machine object that will issue tickets that cost a particular amount. The ticket machine itself does not define how much the tickets will be. That's left as an amount to be supplied when each instance is created. This aspect is in sharp contrast to all of the shape classes that you met in the Figures project, where every square started with the same size, position and color as every other square, and similarly for circles and triangles. Both situations are quite common: default initialization of fields values and external initialization of some or all of the field's values. Let's specify a value of 1000, representing 1000 cents. When we bring up the inspector, we can see that a ticket machine has three fields named Price, Balance and Total. The value of price is 1000, suggesting that the value we supplied as a parameter has been stored in the price field. We can easily check that assumption by creating another ticket machine, passing in a different parameter value, and checking the value of the price field immediately after. Indeed, our speculation appears to be right. That's a useful piece of information, and it gives us something to look for when we start investigating the source code of the class. For now, we'll just work with the first ticket machine and get rid of the other one. Now we can take a look at the methods. There are four: get balance, get price, insert money, and print ticket. Let's try each in turn, and we'll keep an eye on the inspector as well. When we call get balance, we see a method result dialog that tells us that this method returned the value 0. It looks like it was returning the value that's currently stored in the balance field. We can check that idea later if we have a balance field that is non-zero. We see a similar effect when we call the getPrice method. Again, it looks like it's returning the value currently held in the price field. We can see from the Insert Money entry in the method menu that we're going to have to supply a parameter, an integer amount. Let's put in the full price of a ticket, 1000 cents. And we notice in the inspector that the balance field's value has now been updated to 1000. So before we call print ticket, let's call get balance to check our earlier supposition. which proves to be correct. Now let's call print ticket. What appears is called the BlueJ terminal window. It contains something that looks like a printed ticket for whatever runs on the BlueJ line. Notice that the ticket includes the price. Presumably, if we'd obtained a ticket from our other cheaper ticket machine object, then it would have said 500 cents. It will be interesting to find out how the object customizes the tickets it prints so that the price specific to each object appears on the ticket. Notice too that the state of the ticket machine was changed by printing the ticket. The inspector shows that the balance is now 0, but the total is 1000. The money we put in has been transferred to a different field. To summarize, even before we start looking at the source code of the class, we are obtaining some good clues about what might be going on inside it. This will all be useful for helping us to relate what ticket machine objects do to how they do it. We're now ready to start looking at the source code that produces this behavior we've observed, and that's what we shall do in the next video note. In this video note, we've ascertained that in order to create a ticket machine, we have to supply a price for its tickets. From the inspector view, we saw that ticket machines have 3 fields called price, balance and total. We noted that the cost parameter supplied when a ticket machine is created is stored permanently in its price field. When money is inserted into the machine, it is stored temporarily in the balance field. And when a ticket is issued, the balance is transferred to the total field. We also identified that the individually set price of each ticket appears in the printed ticket. We should aim to identify how all of these things are accomplished when we look at the source code.